So the first thing that we want to come to grips with exponents is how do I simplify an expression that involves multiplying, dividing, and raising exponents to powers. So how do I navigate what are called the exponent rules? And the way that I like to think about it, so we're going to take this exponential expression over here and try and simplify it as much as we can. The way that I like to think about it is by following our order of operations frame. By first thinking about what can I do about getting rid of parentheses, if I can. And then after I've gotten rid of parentheses, then I think about simplifying any part of this expression which involves raising a power to another power. Okay? So that's the exponents, it's the E in PEMDAS. And then if I'm multiplying two powers together, I can simplify that by combining the exponents. If I'm dividing two powers by one another, I can simplify that by combining their exponents. And the key thing to remember is that the operation that happens to the exponents themselves is not usually the same as the operation that's happening to the power. For example, if I multiply one power by another power, as long as the bases are the same, then what happens to those exponents is they're not multiplied together. The exponents themselves get added. So each of these different operations that gets done to a power has a different type of arithmetic that happens to the exponents themselves. So what we'll do is we'll unpack this one example and see how all these different exponent properties work in concert to simplify an expression that looks like this. So following the order of operations frame, the first thing I'll do when I look at this, if I want to simplify it, is let's think about this quantity that's in parentheses. First of all, if the quantity on the inside can't be simplified any further, and it can't, then the next thing to look is there an opportunity to take a power that's being applied to the parentheses, so in this example that's this 3, and to distribute that power across an operation inside the parentheses. And when that operation is multiplication or division, the answer is yes, that we can just distribute that power across the division or multiplication on the inside of the parentheses. So just to get into that expression a little bit, inside the parentheses we have x to the 5th multiplied by y to the power negative 2. So I have multiplication going on inside the parentheses and an exponent applied outside the parentheses. That means that that exponent may be distributed across the factors in that multiplication. And what that's going to give me is an x to the 5th power that's getting raised to the 3rd, multiplied by a y to the minus 2 power, also being raised to the 3rd. So that was my first step, to distribute that power across the multiplication inside the parentheses. And then everything else will just carry over for now. X to the 4th on top, and then down here I have xy squared. So that takes care of all of our parentheses for which it's possible to distribute an exponent. The next question is, how do I raise a power like x to the 5th to a power of its own? So if I take x to the 5th and I raise it to the 3rd power, how do I accomplish that? And so the answer to that in our little table here is we're going to multiply. Those exponents, the 5 and the 3, are going to multiply one another. And so at the end of the day, x to the 5th times x to the 3rd is going to give me x to the 5 times 3rd, or x to the power 15. X to the 15. Ditto with my y to the minus 2 raised to the 3. Multiply those together. Whoops. Negative 2 times 3. That's going to give me y to the power negative 6. And now I've done all of my power raised to a power operations. Xy squared is still down here on the bottom. And that takes care of the E in my PEMDAS. So now, let's look at any multiplications that we can do. And there's kind of two sites in which multiplication is happening still in my expression, the numerator and the denominator. So upstairs in the numerator, I've got some multiplications of powers of x and a power of y. Downstairs, I have a power of x multiplied by a power of y. According to our rules, which multiplication am I going to be able to simplify here? Given that the bases have to be the same in order to simplify a product of two powers. Yeah, the only place I can simplify a product is right here, x to the 4th times x to the 15th. And according to that exponent property, what happens to those exponents? How do I simplify them? Add them. So the total number of powers of x that I have is 4 plus 15 up here in the numerator. And so that's going to give me x to the 19th. And then I still have y to the minus 6 on top, and I still have an x on the bottom and a y to the power 2 on the bottom. Okay, and so that takes care of all the multiplication that I can do. So now the last thing I'm going to think about is, what about division? So according to this, if I'm dividing two powers whose bases are the same, then I can achieve that by subtracting their exponents. So I actually need to do that twice here, because I have some x's that are being divided and I also have some y's that are being divided. And if you remember how we multiply fractions, we can treat this instead of as a single fraction. We can break it apart so that there's one fraction with the x powers in it and another fraction with the y powers in it. So that's how we know we can treat those two things separately. If I look at the powers of x, I have 19 of them on top. How many powers do I have down here on the bottom? 1. So that's that hidden exponent, x to the first power. And so if I want to combine x to the 19th divided by x to the first, how do I combine those exponents? Subtract them. So x to the 19, x to the 1. If I subtract, I'm going to get x to the 19 minus 1. That's x to the 18. Similarly for the y's. If I combine the y to the minus 6 and the y to the 2, here's a place for us to make a sign error. I'm going to get y to the negative 6 minus 2, which if I subtract negative 6 minus 2, I end up with negative 8. And now we've simplified everything as much as we can, except that we're going to take one more step in this process. This is a step we won't always need to take, but generally I try to ask for it explicitly in a problem when I want you to take it. And that is, before we finish, I want to take this negative exponent and turn it positive instead. I want to write my answer so that it doesn't have any negative numbers up in an exponent. And so how I can do that is by reintroducing my fraction for a brief minute, just by putting this over 1. And how do I turn a negative exponent positive? Anybody remember how to do this? If I want to make this y to the positive 8, what do I have to do?
Reciprocal?
Yeah, reciprocal. Exactly. What a negative exponent indicates is it indicates a reversal of the role of multiplication with the role of division. So what I want is not multiplying by y to the minus 8, but multiplying by the reciprocal of y to the positive 8. And in practice, what that looks like is just moving the y to the minus 8 term down into the denominator instead of the numerator. And so what we'll end up with is x to the 18th up here on top, and y to the 8th, positive 8th, down here on the bottom. So that's a quick flyover of the different properties of exponents and how we can use them to simplify an expression. Not every problem is going to be this complicated, but this one kind of illustrates all the different ways in which these things work.